greatest common factor as you look at 41?
28.
28. So if I'm doing question 41, I'm going to factor out a 28. That leaves me with h squared plus h minus 2. This should not have been a hard question. This is like we did on h5, not even doing this part. What multiplies to give me h squared? H and h. Has to multiply. Remember, when you look at this, it has to multiply to give us negative 2 and add to our coefficient 1. Well, there's only two options. 2 and 1 multiply to 2. It has to add to 1. Let's do 2, negative 1. That's it. You're done. This multiplies. It gives me the right thing. That's my answer. Question 45. Ugly. No common factor, right? 63. I'm going to use x squared instead of g. Minus 89x plus 30. So the first thing you do to the side, not below the problem, because this is where all your work is going to be. The next step when you do this is you are writing it as 63x squared. You have to have a middle term, and then you have to have plus 30. You have to have two things in here that you are adding. That's what you have to figure out is your split, right? And it has to split to a negative 89. But when you multiply these, which means these both have to be what kind of numbers? If this is going to, they both have to be negative. So this is going to be a minus, this is going to be a minus when you split. So when you multiply and you're taking to the side of this, you're going to take 63 times 30, which gives us a pretty big number, right? What'd you get?
1,809.
1,809. Now I had someone yesterday afternoon that said, you know what, I just started picturing dividing by different things. But here's where you need those prime factors. So you might start off and go, well, 63 is 7 times 9. But 9 can be factored further, right? It's 3 times 3. So you got 7, 3, 3. 30 is 3 times 10. But you might go 3 times 5, 2 times 5. So these are all of your factors. I don't like to list the factors. This is what you have to do to try and figure out different combinations of multiplying. So at this point, you might be looking and you go, oh, I'm going to take and divide. And you take and divide and you try that one and you take another one and you group them, okay? And it's just kind of by trial and error now that you're going to put numbers together. And Brooklyn, we're looking at what?
Negative 35.
So we're going to go with 7 times 5. So please on your calculator right now, take 1890 and divide it by 35. 35 gives us what? 54. 54 and 35. If I add them together, oh, how did I come up with that? Because yesterday Brooklyn and I were working at hers and we kept trying a bunch of different combinations. We started first with going, oh, what if we take 27 times, 30 times 70? Nope, that's too big. And you just keep going with different combinations. So we came up with that one, so that's why I called on her, because it'd be much quicker than me listing and trying to do all of those, and we want to kind of get to the rest of your notes today. So if I put a negative 54x, right, and I put a negative 35x, and now I am going to be factoring my greatest common factor. Brooklyn, did you put it in this order?
No.
Did you put the 35 first?
Yeah.
Okay, so let's put the 35 first, just so we take it the same as you guys. Because I'm going to keep calling it, because I think there's a lot of people that didn't have that. Minus 54. Question, Emma. Okay, so let's wait. Let's get that. So, Brooklyn, when you factored it, greatest common factor, the first one you had what?
7x.
7x. Leaving us with?
9x minus 5.
Okay. And the key thing is, this should be the same thing. Ah, but this is a negative 54, so we can't, and this is a plus. So you can't factor out, what factor, Brooklyn?
Negative 6.
We have to factor out not 6, but we have to factor negative 6. Hang on, just wait. So we factor negative 6, so watch. So Brooklyn, we're going to have
9x minus
9x minus 5. If you would have factored a positive 6, it would have been negative x, 9x plus 5. That have to look the same. Why? Because this is now, and if you didn't have this done, you should have it on your paper. Because I am not doing it for no reason at all. And so if you didn't have it, now everyone is going to turn theirs in with number 45 done. So 9x minus 5 is the common factor. 7x minus 6 is the other one. When we go into our next unit and you are solving, the difference is it's going to be, instead of an expression, it's going to be an equation. This will be equal to 0, and then you'll set each of these equal to 0 and solve. Yeah.
Sometimes it has like a number outside of the parentheses. Why does it have that?
Because like this one, you factored your greatest common factor and you had 28. So 28 was common to all, so I put that out in front. So like when I was looking at, like when I looked at, which one was it, in the 20s, I think it was, where you have a common factor, like in 23, I noticed that I can factor out a 2 first and be left with 4b squared plus 17b minus 15. And I have to keep this as part of the answer, because that's how I would get this original product, okay? So on the worksheet, if I'm looking at yours, the question was with 51, that was one of the other ones that I just want to quickly look at. How do you factor this? This goes back to what we did the other day, right? How do you factor x squared plus 5x that multiplies to 6? So it has to multiply to 6. What am I looking at that multiplies to 6? And adds to 5. 3 and 2. And they're both pluses, right? And the first question, so what are the x-intercepts? X-intercepts is where it crosses the x-axis. Where are they? -3 and -3 and -2. And it says describe the relationship with this. Well, if you put x plus 3 equal to 0, and this is where we go with the next unit. This is a graph of a quadratic. So when we get into the next unit, I, you are going to be looking at solving problems like this. If x plus 3 equals 0, what is x equal to? When you subtract 3 from both sides, right? -3. That's this answer. And when you subtract 2 from both sides, -2. So this is kind of where we're going with this. This is kind of the leading into it question 51. The questions on graphing that some of you are thinking, like 28 and 29 being hard, they give you the first factor. They say 4x squared plus 20x 16. They say, okay, one of the parentheses has to be 2x plus 8. What's the other one? Well, first thing is, what do you take times 2x to get 4x squared? 2x. Now look at the last term. What are you going to take times 8 to give us 16? 2. And then you go, oh, you know what? This must be a plus. Does it give me my middle term? This is 16x. This is 4x. Yeah, that adds to 20x. So what was the answer, the other dimension? 2x plus 2. Don't make them harder than you have to. It's a little clear. Okay? Again, we're thinking of our expressions, terms, factors, coefficients. And now we are looking at, instead of multiplying them, we're factoring. So what gives us x squared? What are my two factors? So go with your two parentheses always. So you're always, anytime it says factor, unless there's a greatest common factor, which in this case there is not, you're going to start with x times x. This was the quiz the other day. If it has to multiply to 16 and add to 8. Multiply to 16, add to 8. 4. So do you recognize this is our special case? This is a plus 4. This one is plus 4. How did we write that the other day when we were multiplying this? We wrote it as x plus 4 to the second. So this is one of our special cases. 4n minus 12, 4n squared minus 12n plus 9. Oh, I have a lead coefficient, but here's something I want you to think about. This is a, what kind of a number 4 is?
Even.
And more specifically, perfect square. So you want to try and identify perfect squares. And the last one is a perfect square. That means it is a perfect square trinomial. Perfect square trinomials can be written as a binomial, two terms, squared. Because there's a minus here, we have to have a minus. Because this was a perfect square and this was a perfect square, we took like the square root of each one. Square root of x squared gave us x. The square root of 4 gave us, or the square root of, not 4, 16 gave us 4. Thank you. This time we're going to take the square root of 4n squared. That's going to leave us with 2n. I'm going to take the square root of 9. 3. If you're not sure you did this right, could you write it out as 2n minus 3 and 2n minus 3? And then check that gives us the first term, 2n times 2n, 4n squared, and the last one. And this is a negative 6n, and this is another negative 6n. So it says, what do we notice about our pattern as we are looking at this? So this is what I would like for you to write down. What we are noticing is this is that same pattern. This first part, so write it down, both of those, please. This first part is called a perfect square trinomial. This is called a perfect square trinomial. Because the first one is squared and the last one, and it's always 2 times our middle. So when we did that, that's where we were, when we were multiplying and you started with these problems. This is called a perfect square binomial. Or actually, they usually put it as a binomial squared. Binomial. And then what are you doing with the binomial? You are squaring. So binomial square. So we've seen this pattern earlier. I'm going to give you a minute to study. And here, what I have written here is the same thing as the next page in your notes, right here, right? This is the same thing, okay? So it says, here's how you recognize a perfect square trinomial. The first and the last terms are perfect squares. So the first and the last term are perfect squares. This is your b squared, this is your a squared. You have x squared, 4n squared, you have 16 and 9. Perfect squares, thus the memorizing of perfect squares earlier this year. The middle term, when we take a look at our middle term, the middle term is always twice the product of the first and second factor. So it's the same as taking 4 times 9, or if we are looking at this, 2 times 3, which is 6, doubling it to get us the negative 12n. 4 times 1, doubling it to get 8x. So when we are looking at those terms. So it says any trinomial of the form a squared plus 2ab plus b squared, or subtracting that middle term, 2ab, is called a perfect square trinomial. Because the result of squaring the binomial, reading the equation above from right to left gives us our rules for factoring. So the reason that this is nice is pretty soon when we go to solve, this is going to only have one solution for our quadratic. That last one in 51 that we did had 2 solutions. This one, both of these will only have one solution when we get to our next unit. So, as you are noticing on the top of the next page, we're on 21. It says factor x squared plus 6x plus 9. So our first term a is really 1. So the a is not the x. I'll have a lot of people say, oh, okay. So that's the coefficient of your x squared. It's 1. The b in this case is that last constant, which is 9. So what we want to think is, oh, okay, can I take, that's b squared and a squared. So what I have to do is I have to take that middle term. So I want to be thinking, oh, what is the square root of both of those? Well, the square root of 1 is 1x. The square root of 9 is going to be 3. And now if I take and multiply these two times 1 and times 3, right? Why 3? Because it's the square root of 9 that we are looking at. That gives us 6, which was our middle term with the x. This is my answer. I will have some of you that don't like to write it this way. You want to write your answer like this on the test. I'm okay with that. I really don't care. As you get into more of your upper level math classes, and as we go to graph, this is going to be in that form of our, remember when we did linear and we did point slope form? This is how we're going to graph. This is going to be point slope form when we graph quadratic. Only thing it's going to be the, it's called the parent function when we look at it that way. So let's look at these two. 64x squared minus 144. Oh, first thing we notice, perfect square, right? Perfect square. So the square root of 64, so A is going to be, if we are looking at it, 8t. B is going to be 9. 2 times AB, so 2 times 8t times 9. 16 times 9, if you want to multiply your calculator. Does that give us our middle term? 144. Now, notice we didn't have a minus 144. We just have 144 with t. So since it's a minus, that means that they both had to be like negative. So I'm going to have 8t minus 9 squared. As I am looking at that solution. Please try the next one, because we noticed right away 36 and 25 are perfect squares. Okay? So try that next one if you would, doing it right now, the same way we did this last one. So if we are starting and you are filling in your notes, the first thing we are going to take a look at, Caleb, are you ready? Okay, starting off, I'm going to have
6.
6. And we're going to keep the H with it in this case. And then my B, as I'm looking at it, Emily, is going to be 5. And so now, Laura, if I'm looking at 2AB, 2, 6H, 5. So this gives me 30 times 2 gives me 60H. That's what I wanted for my middle term. So yes, if it's yes to both of these parts above, then you can fill it in as 6H, and in this case, since it's a plus in front of 60, plus 5 for our answer. You are done with the problem. This is it. This is your answer. Okay? Top of the next page, remember the other special case was up at the top, difference, and remember when we did different in sum? So the difference of 2 squares. So notice that we wrote behind here, x squared minus 16, Angus, question, is equal to the same as x squared. That's like a 0x in the middle. So again, you have perfect squares, right? We are going to go with, what do you multiply to get x squared? X and x. What do we multiply to get a negative 16? Negative 4 and positive 4. Sum and difference, right? Does that give us a middle term of 0? Yes. 4x minus 4x. So again, this one, perfect square minus another perfect square. Difference of 2 squares. This is where we are going to go with the square root of 4y squared. The square root of 4y squared is 2y. 2y times 2y is going to give me 4y squared. So I put that as the first thing in each parenthesis. Next thing I'm looking at, it has to multiply to give me a negative 25. That means I have to have a plus and a negative. Does it matter if you go negative 5 and positive 5 and someone else puts positive negative? It doesn't matter. That still gives me 0 as a middle term. So the question says, what do we notice about our pattern? So when we are taking a look at our pattern, I'll let you copy these down that I have. As we are taking a look, this is what you want to write down in your notes. So a minus b squared is always going to be equal to the sum and the difference. Where did we see this earlier? In lesson H4. When we were multiplying our special polynomials. When can you use patterns? Key thing to look for is that you must see a difference of squares. With that perfect square trinomial, you must see something added with that middle term being 2, but the difference is a subtraction problem of a square. If you would have had this problem and it says factor x squared plus 16, they're both perfect squares, that can't be factored. You cannot factor this. X squared plus 16, they have nothing in common. That is, and there are problems that you cannot factor. It's possible that you can't factor it. There's no common factors. You do the AC split thing that we did today. You can't factor it. That's possible, okay? So this one, x squared plus 16, can't be factored. And the reason being is that you're going to see when we get to the next unit That one has no solution when we go to graph it. There's no answer for that. There's no solution. So the difference is subtraction. The square refers to the perfect squares. When you see a polynomial, you're looking for a past. Sure, if you like x's better than z's because your z's look like z's, make it an x. Every variable, if you don't like the variable that they're giving you because you know I can't read your writing when I see some of those other variables, keep it as an x, right? So x squared minus 9. When we are looking at it, our a is going to be 1x. What is our b going to be? 3, right? Because we're taking this, because b squared, we're taking the square root, right? You're always taking the square root of it. So in this case, that means when I look at it, that special case, if we're filling in our blanks, we are going to have x, and you don't have to put the 1x. You can just put x plus 3, x minus 3. Next page in your notes. Take a look at these two. Are they perfect squares when you look at b squared 100, when we look at 25d squared and 64? And again, if you don't like using d squared, use x squared. I don't care. Right? If you don't like using b, use x or y. So if I'm looking at it, first question, is the binomial a difference? Yes. Is this one a difference? Yes. Difference means they were subtraction problems. Because if it's an addition problem, you can't factor it. Okay? Next thing, are a and b both perfect squares?
Yeah.
Yes, in both cases.
Yes.
List your a. If I'm looking at the a, I should have what, Lise, for my first a? B. And for the b, I should, Jack, have 10. So I am looking at writing it, Lizzie, as
b plus 10.
Yep, and then Colin.
B minus 10.
Yes, we're going to go to this next one. We said they're binomials. So if we are looking, Aiden, what is our a going to be?
5d.
5d. My b is going to be, Emma? 8. If I am looking at writing it, my first one would be 5d plus 8. The second one, Christian, is 5d minus 8. I don't think I did it right. Do a check. 5d times 5d, that gives me 25. 8 times negative 8, negative 64. Middle term. 40d and a negative 40d. That adds to 0d. That adds to no middle term. Okay? As you are looking at that last one, it says, what is the factored form of this? And you start and you go, whoa, it's a difference, but they're not perfect squares. Find your greatest common factor. Is there a number that goes into both 12 and 48? 12. So we want to start this problem, and you have to keep, this is where some of you are like, where's that number that's out in front? I don't get how they got that. That was the greatest common factor. We're going to keep that. We factor out the 12, instead of t, I'm going to use x, because some of your t's look like pluses. So I'm going to have x squared minus, what do I take to get 48? 4. So, is it a difference? Yes. Are a and b perfect squares? X squared? Yes. What are they? X and 2. So then I'm going to go with x plus 2, x minus 2. The question is, do we have to go through and write all this each time? No. But this is kind of what you should be thinking in your head when you do the problem. You should be thinking, oh, this is how I do it. And instead of doing the work behind, do it below. Those of you doing it behind, because when we go to solving, you don't want to have it done that way. So, you are looking at your assignment. You start with number 9. Again, when you look at the problem, first thing when I look at your paper for 9, I want to be able to see that you've written the problem down. I don't want just the answer. So when I look at number 9, on your paper, this is the work I should see. H squared plus 8h plus 16. And I'm trying to think, is this a perfect square trinomial? Meaning, when I look at the problems, is this a perfect square? Is this a perfect square? And is my middle number, right? So at the top, a squared 2ab plus b squared.
so
These are the two forms we are looking at, correct?
You want to grab
Those are our perfect square trinomials. Quietly, just sit down, please. When I look at this, I'm looking perfect square, yes. A squared and b squared. Is the middle term 2 times the square root of my b squared? The square root of 16 is 4. So h, we think plus 4. Does that give us the right middle term? 2 times 4h, 8h. My answer has to be this square. If you don't like to write it this way, and you would prefer h plus 4 times h plus 4, you can leave it like that. But generally, this is how you're going to see the answer in the back. Okay? I don't care if you write it out like this. These mean the same thing. Yes? Because all the rest of it is kind of the thinking in your head. So when you were looking at your notes and all of this stuff that we wrote down, like this kind of stuff, this was like, how do you think about this problem, right? This is like, oh, what are the 2 factors? That's what you should be thinking or putting to the side if you need to. But yeah, there's really not that much work. Similar when you were doing last night's homework, when you did the 6 and the 520, that H6, you should have been doing the work with multiplying your factors to the side. And this is still your answer as you look at it.